Good morning students. Today we are going to discuss about mass. Okay, mass is nothing but what? It is one of the fundamental quantity, correct? No, which we had discussed the 7 fundamental quantities. In those 7 fundamental quantities, one we are having, that is nothing but mass, correct? So mass is nothing but, first of all, it is a basic property of nature. That means if we are considering any object, if I consider this chalk piece in my hand, means this chalk piece is having its own mass, correct? No, if you consider me as the object, means I will be having specific value, okay, as a mass. That means 70 kg, 65 kg, 68 kg, whatever it may be, okay. So that mass is nothing but, if you consider any object, that object will be having what? It is having its own particular value for mass. And what is the SI unit for mass? SI unit for mass is nothing but what? Kg, correct? So about mass we are going to discuss. So in NCERT, if you consider, means if you refer, means in NCERT, measurement of mass. Okay, under this section you will be going to see this. Clear? So SI unit for mass is nothing but what? It is kilogram and written as kg. Clear? So SI unit for mass is nothing but kilogram, and one of the most important thing what I want to tell you is, this mass is independent of temperature. That means if we increase temperature, imagine a iron rod, clear? So if mass of the iron rod at room temperature, let us suppose it is of 2 kg, clear? So what we are going to do means, for the 2 kg iron rod, we are offering some temperature. That means we are going to heat it. Okay, we are giving some temperature to that, and when we are going to heat that complete iron rod, after heating also, if we want to check what is the mass of that iron rod, means again you are going to get that same value, that is nothing but 2 kg. So what we can come from this point means, mass is independent of, yes, independent of, what is that? Temperature. Clear? Mass, it is independent of temperature. And it doesn't depend on location also. Location means, if you measure mass of the chalk piece here, if you are going to get 10 grams, means if the same chalk piece, if I give you to your home, means in your home also, if you check what is the mass of that chalk piece, means again same 10 gram only you are going to get. Clear? So this mass is such a quantity, okay, it is independent of location. Clear? And one more thing what we are going to discuss is, even if we increase pressure for that complete object, at that time also we are not going to get different value for mass. Clear? So this mass is a quantity which is independent of temperature, clear, as well as location where you are going to measure mass, okay. That space is or that it is independent of the location. And one more thing, this mass is independent of pressure, correct? It is independent of pressure. Clear? So first of all, mass, it is nothing but a basic property of an object, and it is independent of location as well as temperature and pressure. And SI unit for mass is nothing but what? It is kilogram, kg. Clear? And what we are having means, to standardize this mass, okay, we are having one system, that is that institution name is nothing but DIPM. Okay, so International Bureau of Weights and Measures. Okay, International Bureau of Weights and Measures. Actually, they will give you a model of mass. That means it is treated as protocol of mass. Okay, just a basic model of mass. And for all the countries they have supplied. So just a basic example how you can visualize this means, In earlier days, in olden days, if you just come across, means in market, still today also in market, they will be not using digital weighing machines. Clear? So they will be measuring like scale pans. Okay, 2 pans will be like this. Here they will be keeping some standard weights, and in one more pan they will be keeping the required quantity, what you need. For example, sugar, jaggery or dal, whatever you are demanding, whatever you are in need, that they will be keeping in one pan, and in one more pan they will be keeping the standard weight. Okay, so this BIPM, it is a what we can call, means it is a standard actually. So they had supplied for all the countries. Okay, in India we are having at NPL, that is nothing but National Physical Laboratory. Okay, in India we are having it as New Delhi. Okay, in New Delhi we are having that NPL. NPL means National Physical Laboratory. Okay, here I had written NPL. This is nothing but NPL. Okay, so this National Physical Laboratory, in this National Physical Laboratory in India we are having the protocol which has been given by this BIPM, National Bureau of Weights and Measures. Okay, full form for this BIPM. Okay, slight changes are there, but you are going to treat it as International Bureau of Weights and Measures. Clear? So this kilogram, it is a SI unit, no doubt. Clear? And whenever we are going to see a small objects like nucleus or electrons, in such cases this kilogram unit is not appropriate one. Okay, this is just an inconvenient unit, we can tell it as. Correct now? So for measurement of small objects such as nucleus, such as electrons, we are going to treat one more standard unit, that is nothing but Unified Atomic Mass Unit. Okay, so Unified Atomic Mass Unit. Okay, Unified Atomic Mass Unit. So what is this Unified Atomic Mass Unit means? It is treated as one atomic mass unit, one AMU. Okay, it will be written as atomic mass unit, or it can be written as one AMU. So this one AMU is nothing but, this is 1 by 12 times of carbon 12 isotope, yeah, which is nothing but 6C12, and along with this electrons will be also present. Okay, one AMU is nothing but 1 by 12 of mass of atom of carbon 12 isotope, which is nothing but 6C12 plus electrons also. That means including electrons we will be treating this value. So one AMU value, one atomic mass unit value, it is approximately 1.66 into 10 to the power of minus 27 kgs. Yeah. So one AMU is nothing but 1.66 into 10 to the power of 27 kgs. And I hope you might have remembered while discussing basic forces in nature in physical world, we had came across one important force, that is nothing but first force, gravitational force. It is nothing but what? Weakest force in nature. Clear? So the masses of large objects such as sun, moon, earth, okay, masses of these large objects we will be going to get it through the Newton's laws of motion, Newton's law of gravitation, okay, which gives us that force between two objects in any two objects in our universe, that is nothing but proportional to product of their masses and inversely proportional to what? Square of distance between them. We had written this, F is proportional to m1 m2 divided by r square. Okay, with that law we are going to calculate masses of larger objects, that is nothing but Newton's law of gravitation. And normal masses like mass of sugar or jaggery, These masses nothing but we will be measuring through what? Which is that normal physical balance, okay, normal scale balance, what we used to call. Using that we are going to calculate. And one more we are having, for measuring very small objects, we are having a special instrument which is known as mass spectrograph. Okay, in that mass spectrograph, first of all, that mass spectrograph will use electric fields as well as magnetic fields. Clear? Electric field is nothing but when a current is flowing through the conductor, then it will be creating some magnetic field around it, and no doubt it is an electron. We will be having electric field also, and a static charge. Okay, when electron is at rest, it will produce only electric field, but when it comes under motion, means when a charged particle like electron, when it is moving, means moving with some velocity, means then what we will be having means it will create magnetic field around it. Okay, when the electron is moving, it will create a magnetic field around it. So this mass spectrograph, it will use both electric fields as well as magnetic fields. Okay, why we are using this mass spectrograph means to identify masses of very small particles like protons, clear, like electrons. So what we are doing means in that mass spectrograph, these charged particles, okay, mass of which mass we are going to measure. Suppose example, if I want what is the mass of proton, so that proton we are going to we are making that proton to enter in that mass spectrograph, and in that mass spectrograph that charged particle will undergo the effects of both electrical as well as magnetic fields. Okay, when it is undergoing both electrical and magnetic fields, it will just deviate like this in curvature manner. It will just deviate, and using that curvature manner, okay, if it is undergoing in this manner, slight curvature in this manner, means, okay, if we consider only this part of the curve, means, are you just following what I am telling? Okay, it will just undergo in this manner, curvature manner. If I want to complete this complete circular, means, okay, imaginary circle if I consider, means that circle will be having some part of some value of radius, correct? No, that radius of curvature, it is directly proportional to mass of that object. Using that concept, we are going to measure what is the masses of small particles like such as protons and electrons. Okay, have you all followed? First of all, mass. Clear? How you can tell simply mass is nothing but it is a basic property of object. Okay. Then SI unit for mass is nothing but kg, and it is independent of temperature, location as well as pressure. Okay. So this BIPM means International Bureau of Weights and Measures. Okay, they had supplied for all the countries the standard weights. In India, we are having it at New Delhi. And in New Delhi, we are having a specific office for this. This is nothing but NPL, National Physical Laboratory. In there we are having actually those weights. And for measuring small masses, we had come across one more important unit, that is nothing but Unified Atomic Mass Unit. So Unified Atomic Mass Units, 1 AMU. AMU means Atomic Mass Unit. This is nothing but 1 by 12 times of mass of atom of carbon 12 isotope, that is nothing but 6C12 plus including electrons also. Clear? Because that atom contains electrons also. Next, that value will turn across 1 AMU is equal to 1.66 into 10 to the power of 27 kg. Okay? Remember this value. You need this value. Clear? While solving numericals and all, you will require this value. Clear? So if you found value in terms of AMU, means simultaneously you can convert that AMU value to kg just by using conversion. 1 AMU is equal to 1.66 into 10 to the power of minus 27 kg. Clear? Shall I erase the board? Clear? So now we are having we had discussed about length already, correct? No? And measurement of direct measurements, indirect measurements also we had came across. But in this length, we are having first one. This is nothing but astronomical unit. This astronomical unit is nothing but the mean distance the mean distance between, or mean distance from earth to sun, or mean distance between sun and earth. Clear? So the mean distance between sun and earth, that is treated as astronomical unit, and one astronomical unit. Clear? This one astronomical unit, this value is nothing but 1.496 into 10 to the power of 11 meters. Clear? This is just a basic formula or basic conversion. You should have to remember one astronomical unit is nothing but 1.496 into 10 to the power of 11 meters. That means length between, or length of the sun from earth. Okay, in that manner we are calculating. That value turned out to be 1.496 into 10 to the power of 11 meters. Clear? You can note down this. Shall I erase the board? Clear? So what we came across, one astronomical unit, it is nothing but how much more? 1.496 into 10 to the power of 11 meters. Clear? So next one we are having light year. Okay. We are measuring large distances through these units also. Clear? So this light year is nothing but the light travel in vacuum in 1 year. That means the total distance of the light which has been travelled in vacuum for 1 year, that value we are going to calculate. You know that simple formula speed is nothing but what? Distance divided by time. Correct? No? Now we are concentrating on distance. Okay, so if you separate here, distance means what I can write? Distance is equal to, so if I cross multiply here means what I can write? Speed into time. Clear? So speed is nothing but, this distance is nothing but total light year value. Okay, total distance, how much it has covered, that value we are going to calculate. So speed is nothing but speed of this light wave. Okay, you already know what is the speed of light, how much, what is the value for that? 3 into 10 to the power of 8 meter per second. Okay, that is nothing but speed of light. So 3 into 10 to the power of 8 meter per second. Next, time means for how much time this light has to travel. Clear? This time is nothing but for 1 year it has to travel. Correct? No? The speed of light, okay, the light wave which is traveling with speed of light, which is nothing but 3 into 10 to the power of 8. Okay, this light wave is traveling with this much speed for 1 year. Okay, that total distance we are going to calculate it now. So I can write here so distance, this is nothing but 1 light year we are going to treat it as. This distance is nothing but, so we are going to substitute values. Speed of light is 3 into 10 to the power of 8. Okay. Now this complete year value, this 1 year value, we are going to convert it in seconds. Why? Means this value is nothing but what? Meter per second. Meter divided by second. This value if I convert it in second means second will get cancelled. Meter divided by second into second. Correct? No? Second will get cancelled. Only meter value, which is nothing but SI unit for length, we are going to take that value. Correct? Are you all understanding? So here what I can write, 1 light year is equal to 3 into 10 to the power of 8. Now question arises, how to convert this 1 year into seconds? Clear? So 1 year consists of how many days? Okay, in generally we are going to consider it as 365 days. Clear? If you are getting leap year means 366. Okay, but maximum times we are going to consider it as 365 days only. because maximum times we are going to get 365 days only. Correct? So 365 days. In one day, how many hours we are having? Okay, one day consists of 24 hours. Correct? In 1 hour, how many minutes we are having? In 1 hour, we are having how many minutes? 60 minutes. Clear? And in 1 minute, how many seconds we are having? Again, in 1 minute, again we are having how many seconds? 60. Clear? So 3 into 10 to the power of 8. Okay, into one complete year I had written in the units of seconds. 365 into 24 into 60 into 60. Okay. So if you calculate this value means you are going to get 9.46 into 10 to the power of 15 meters. Clear? Because second will get cancelled. You are going to get final value in terms of meters. Clear? 1 light year is equal to 9.46 into 10 to the power of 15 meters. Clear? Shall I erase the board? Shall I repeat once again? This light year is nothing but the light travelled in vacuum in complete 1 year. That distance we are going to calculate. Clear? Just by simple formula, speed is equal to distance by time. We are separating distance. Distance is equal to speed into time. Speed is nothing but speed of light wave. Clear? Speed of light, how much it is? 3 into 10 to the power of 8 meter per second. Okay? For time means for how much time this light wave is moving with this much speed? That is nothing but 1 year. Clear? So this 1 year completely I had converted into seconds. That is nothing but 1 year consists of 365 days. Clear? And in each day we are having 24 hours. Clear? In 1 hour we are having 60 minutes. And in 1 minute we are having 60 seconds. Clear? So if you calculate this complete calculation means approximately you are going to get 9.46 into 10 to the power of 15 meters. Clear? Shall I erase the board? Clear? So what we came across, 1 light year is equal to how much? 9.46 into 10 to the power of 15. Clear? Next, third one we are having parsec. Clear? So imagine that here we are having sun. Clear? Here we are having earth. So distance between sun and earth, what we had treated it as? Distance, mean distance between sun and earth, what it is? 1 astronomical unit, correct? So this distance between the sun and earth we are going to treat it as a curve. Clear? Distance between the sun and earth we are going to treat it as a curve, and this curve is subtending an angle of So this curve is subtending an angle of 1 second here. Clear? This 1 to the power like this, if they had given, means this is treated as 1 second. Clear? So, clear? Are you all following? So, you can imagine in this manner. So this part is nothing but what? For this circle, this part is nothing but what? Arc of the circle. Clear? So this distance we are going to treat it as what? Parsec. 1 parsec. Clear? So what I can write here means, now you are having question, sir, what is this angle 1 second? Clear? So I will tell you. So always remember, 2 pi radian is equal to 180 degree. This degree, I hope you are familiar. Clear? Oh, sorry. So 2 pi radian is equal to how much? 360 degrees. So from this conversion, this degree value you are familiar. in your school days, clear? And I had informed you what is this radian. What is this radian? This is nothing but for plane angle, unit for measuring plane angle, that is nothing but what? Radian, correct now? So from this conversion what I can take here means for 1 degree, okay, for 1 degree if I choose means what value I am going to get here? Can you just tell me? So 1 degree is equal to 2 pi divided by 360, correct? Or 1 degree is equal to, if you just cancel it out means 2 ones are 2 180s are, so pi divided by 180 radian. So 1 degree is nothing but pi divided by 180 radian, clear? So this 1 degree, okay, I can write it as 3600 seconds is equal to pi by 180 degree, and this value, it is again equal to 60 minutes, okay? If single mark is there means you are going to treat it as minutes, clear? If double mark is there like this means it is nothing but seconds. Once again I will write it here, okay? You are not going to see here. So 3600 seconds is equal to pi divided by 180 radian, yes, which is equivalent to 60 minutes, clear? So from here, if I want to consider from these two steps, okay, for value for 1 second, if I take value for 1 second, what value I can write here? Pi divided by 180 into this 3600 should come in denominator, 1 divided by 3600 seconds, okay? This, otherwise I can remove this second. Somehow here I had informed 1 second, it is nothing but pi by 180 into 1 by 3600 radians, okay, totally. So you should have to remember this conversion. Only this much if you remember means 3600 seconds, which is equivalent to 60 minutes, that is equal to pi divided by 180 radians. From this you are going to get 1 second is equal to pi by 180 into 1 by 3600 radians. Clear? Shall we go to next step? Shall I erase the board here? This part I will be erasing, this part as it is I will be keeping. Shall I erase? Clear? So I had informed you, okay, while measuring large distances, angle is given by, okay, in generally if we write angle means, as theta means, I will be writing in bracket angle. This will be given by what? R by radius of that circle, correct? So here angle what we are having? Here we are having 1 second, clear? So 1 second is equal to arc value. Arc means this value, clear? So for arc what is our value? 1 astronomical unit, 1 AU, clear? Whole divided by radius of this circle. Clear? This imaginary circle what I had drawn with this dotted line. What is the radius of this circle? This gives is nothing but parsec. Okay? 1 parsec. So 1 parsec. So our ultimate aim is to determine what is parsec. 1 parsec value. So 1 parsec is equal to 1 astronomical unit whole divided by 1 second. So if I want to continue here means, what is our 1 astronomical unit value? 1.496 into 10 to the power 11 meters whole divided by 1 second. How we have to write 1 second value? Already I had written conversion earlier. What is that conversion? 3600 seconds, okay, which is equal to 5 divided by 180 radian. Okay, this value equal to 60 minutes. From this 1 second, how I can write? 5 by 180 into 1 by 3600. Correct now? So this 1 second value here we are going to substitute. So what I can write here? Pi by 180 into 1 by 3600. Clear? So 1 parsec is equal to 1 astronomical unit value. How much it was? 1.496 into 10 to the power of 11 whole divided by 1 second is nothing but 5 by 180 here into 1 by 3600. So if we calculate this value, means approximately we are going to get it as 3.08 here into 10 to the power of 16 meters. So value for 1 parsec is nothing but 3.08 into 10 to the power of 16 meters. Clear? Shall I erase the board? You can note it down. Okay? Clear? So now we are going to discuss about time. Okay? To measure any incident, okay, from starting point to ending point means we require this time, correct? No? To determine time interval, basically we need a clock to determine this time. Clear? So we will be using atomic standard of time, okay, which is known as atomic clock or cesium clock. Clear? So this cesium clock, it is very accurate clock. Clear? In 1 mark they might ask you, okay, which clock will give us accurate values, which clock will give us accurate readings in measuring time. Okay, in such cases you should have to answer for cesium atomic clock. Okay, you can mention cesium atomic clock will give us very accurate values. Clear? So this cesium atomic clock, in this cesium atomic clock, how we are defining second means, okay, we are defining only the value of second. Okay, with the help of second we are going to discuss all those values. That means hours, okay, how we are going to complete a day based on this, all these only. Okay, so in the cesium atomic clock, 1 second we are going to measure as, it is nothing but we will be considering the cesium atom which will be in ground state. Okay, and some transitions will be going on. So in 1 second how many transitions will go on, that value I will be writing. So that is nothing but 919 crore 26 lakh 31,770 vibrations it will complete, okay, in only 1 second. That means how we can define means, to complete these many vibrations, okay, to complete these many vibrations, this is known as 919 crore 26 lakh 31,770 transitions will be going on from ground state of the cesium atom. Okay, not exact state of the cesium atom, just ground state of cesium atom, it will be undergoing these many transitions. So time taken to complete these many transitions is nothing but 1 second. That means in 1 second it will undergo these many transitions. Clear? And in India, again we are having at NPL, that is nothing but situated at New Delhi. There only we are having the actual setup of cesium atomic clock. Okay, and they will be having the responsibility of maintaining Indian standard timing. Okay, I hope you might have seen this IST when watching matches which are going to head in abroad and all. They will be mentioning 2 timings over there. One is for Indian watchable people, for Indian televisions they will be giving IST timing. Yeah? And in other countries they will be having their own standards that they will be preferring. So IST means Indian Standard Timing. So they will be having the responsibility of maintaining all such kind of things. Clear? And Remember the cesium atomic clock, it will give us very accurate reading. Clear? And how much accurate the cesium atomic clock means, it will be giving us the value up to 10 to the power of minus 13 second. Can you able to imagine 10 to the power of minus 13 second? Clear? In 1 second if we make 10 to the power of 13 parts means, in those many parts only one part if we want means that accuracy also this cesium atomic clock will give us. Okay, that is the importance of cesium atomic clock, which gives us the accurate values till the order of 10 to the power of minus 13 seconds. Clear? I hope you might have watched a complete video. Okay, go through NCERT material. If you have any doubts means after commencement of college you can freely ask us. Clear? All the best for your midterm exams. Read well. Thank you.